Hello everybody, let's debunk some mathematical conspiracy today. We today are in a fortunate situation that we can find on the internet all kind of stuff. We will find what they teach us in math, and we will also find the truth, and it's upon your mind to make sense of it and to see which of those is really the truth. So let's just see what I'm talking about. You may have seen a sketch like this on the internet. A circle, well, this should be a circle with a diameter of length 10, and in the middle we have a perpendicular radius, so that must be half the diameter, so it must be 5, and then we have this line segment, and this is of length 7. You can find this on the internet, but I won't tell you exactly where, because who knows, somebody might just destroy that image or take the website down or whatever just to prove me wrong. So what I am going to do is something that you can try at home as well, so you never trust anybody but your own mind, thoughts and measurements, and I'll show you what you should expect to find. If you've had enough of mathematical indoctrination, you may just say, wait, this must be wrong, because this is a right triangle, and here this is also half the diameter, so it's of length 5, and in such a triangle we should have Pythagoras, so this should read 5 squared plus 5 squared equals 7 squared, but this is not the case. Because if you compute this is 25 plus 25, that equals 50, and this is 49, so that's not 50, and we see Pythagoras is wrong in this sketch. They will tell you in math that this line should actually have an irrational length, and well, I was just trying to teach you rational thinking, so this is just a pure contradiction to that. This is actually a fact about all squares. Well, don't mind the circle, because this sketch is originally for computing the true circumference of a circle, but what we are interested today now is this square. If I would add these lines here to form a square, also of length 5, then I see I have a square with a diagonal, and so what we try, or will try to verify in the measurement just in a minute, is that in a square we have the length of the edge is to the diagonal as 5 is to 7, and this is the real truth of the numbers behind these. So to check this, I made a little drawing, so I hope you can see everything. Unfortunately I should have made it with straight edge and compasses, but well, it would have worked with a compass roughly, but I don't have a compass, and my good old straight edge is from school days, and it has seen so many days that it's really not any straight edge anymore. I would have some very wiggly lines here. So this is made by the computer with Inkscape, or you could have done it with SketchUp or whatever. You can try this at home, or maybe you, if you have the equipment and the calm fingers, you may really try to do this with a real straight edge and compass construction. So let's make measurements here with my ruler. This is really not my broken straight edge, but I just found in the internet a line of centimeter markings. Yeah, right. I remember here that I wrote centimeters, so for anybody working in inches, just make the adjustment or make your squares of different sizes. So let's see what I have here at last. So I'm interested in these 4 small squares. They are all the same, and we see this edge is 10 centimeters. This edge is 10 centimeters, Here again 10 centimeters. I could try them all, they're really all the same. That's what here, 10 centimeters, so it's both the upper edge of that and the lower edge of that. 10 centimeters. All across it's 20 centimeters, so this is also 10 centimeters. So these squares all are 10 centimeters by 10 centimeters. What does this tell us? Let's do the computation. So we had an edge of 10 centimeters. Let's compute the diagonal. So we divide 10 centimeters by 5. That's 2 centimeters. And then 2 centimeters times 7. That's 14 centimeters. So let's check this, if this is correct. I'll try this one. It's 14 centimeters exactly. This one as well. 14 centimeters exactly. Others would have told you that's 14.1 something, and that's clearly not the case. This is 14 centimeters, just as our formula predicts. So what next? You see that this is again a square. Or maybe you see it better like this. A square with its own diagonals. So we can repeat our computation for that square, and you have an edge of 14 centimeters. So 14 centimeters divided by 5, that's 2.8 centimeters. 2.8 centimeters times 7, that's 19.6 centimeters. So our formula says that the diagonal is 19.6 centimeters. Thank you. Let's see the measurement. And here you go. It's exactly 19.6 centimeters. So this shows that this is the truth and this is just plain wrong. I just suggest you repeat this at home with a maybe even larger square. Really try to do it with a straight edge and compass construction, so you have to really have a square and not just some rough approximation to square. But the approximation of this printout was really better than half a millimeter, maybe better than I could have done with straight edge and compass. So just repeat this at home, do your own measurements, only trust your own mind, and don't give a damn for these fake math that you find everywhere else on the internet.